Hello and good morning, or afternoon, or evening, depending on where in the world you may be. We are eagerly awaiting the New Horizons team going live once again with whatever information they may have from their mission. We are currently staring at a standby screen on NASA TV. And the Deep Space Network is no longer receiving signals from the spacecraft. So hopefully they got what they needed, because right now the spacecraft is looking, the dishes are looking at a different spacecraft. Now, part of that is planetary rotation. As our planet rotates, the signal goes from one dish to another. So to give you an update on what we know so far, the spacecraft returned telemetry and basic information from many of its instruments. Well, here we go. Let's just see what they have to say.
Happy New Year. We are live at the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland, where space exploration history is being made in front of our eyes. I'm Mike Buckley from APL's Office of Communications and Public Affairs. And this morning, NASA's New Horizons spacecraft at 12:33 a.m. flew by a Kuiper Belt object nicknamed Ultima Thule, the farthest flyby in history. This morning, at about 10:30, the spacecraft phoned home, sending a signal back to mission operations here at APL to let us know that it was healthy and it collected all the data we asked at Ultima Thule. We're here this morning to have members of the team bring us up to date on spacecraft status, show us some of the latest images, and then lay out what's ahead. We'll be taking questions from the media here at APL and over the phone, and we encourage everyone watching online to follow us with the hashtags Ultima Thule, Ultima Flyby, Ask NASA, and Ask New Horizons. Now, on our panel today is New Horizons Principal Investigator Alan Stern from the Southwest Research Institute, New Horizons Mission Operations Manager Alice Bowman from the Johns Hopkins Applied Physics Laboratory, Mission Systems Engineer Chris Hersman from the Johns Hopkins Applied Physics Laboratory, and New Horizons Project Scientist Hal Weaver, also from the Johns Hopkins Applied Physics Laboratory. The panel will make some statements, and then we'll take it out for questions. Your show.
Well, I don't know about all of you, but I'm really liking this 2019 thing so far. We're here to tell you that last night, overnight, the United States spacecraft New Horizons conducted the farthest exploration in the history of humankind, and did so spectacularly. Thousands of operations on board the spacecraft had to work correctly in order for us to be able to tell you this, and now we know that it all did. And so let me turn it over to our mission operations boss, Alice Bowman, to say a little bit more about that.
Thanks, Alan. We had a great support with Madrid Station, Deep Space Network, 70 meter. You saw that we locked up to telemetry on the spacecraft. Everything looks great, and we are definitely looking forward to getting down this science data so all of our scientists and the world can see what the outer solar system, the origins of our solar system, have to hold for us, what surprises. So, Chris?
Thank you, Alice. I'm Chris Hersman, the Mission System Engineer, and I just wanted to give you a little feeling about what it was like to be in the Mission Ops Center. The first person to report was the RF communications lead, and we kept our eyes on him, and as soon as he started smiling, we knew things were going well. And it took a while for him to report, but then we go to the C&DH lead, and he reported that the solid-state recorder had the right amount of data he expected. We also went to the propulsion lead. He said the tank pressures look good. And we just went around the subsystems, the power, everybody reporting green status, and it was just a thrill. And then the cheers erupted in the Mission Operations Center. It was an amazing experience. And I'd like to turn it back to Alan. He was rushing in from the Situation Room to congratulate Alice on her accomplishment.
Yeah, well, what I want to do next is tell you a little bit about the science, and then Hal Weaver, our project scientist, is going to tell you even more. Yesterday, we started to get some pre-arrival data taken from about 500,000 miles out. So these are still very low-resolution images, but as we speak, right now, signals from the spacecraft are coming back across the solar system at the speed of light. They're currently about halfway back to Earth. And overnight tonight, the science team will be analyzing the first high-resolution images, which we'll be able to show you tomorrow. Now, the image that I'm about to show you is the best image of Ultima that we got pre-flyby, and it's okay to laugh, but it's better than the one we had yesterday. There it is. Meet Ultima.
It looks like one of those clown punching
So,
bags.
in my line of work, we like to interpret even images like this. And so what can we tell you from this image? Well, first, we have a better handle on the size of Ultima. It's about 35 by 15 kilometers, and you can see a scale bar in miles there. Secondly, you see its irregular shape, and there are two possibilities here. One possibility is that it's bilobate, with the upper lobe being smaller than the lower lobe, so they would be asymmetric. Or it may be that these are two things that are actually in orbit around each other and just blurred together because of their proximity. Tomorrow we will know which of those is the case. Now I'm going to turn this over to Hal to give you some even more exciting results.
Okay, thank you very much, Alan. As you said, what a difference a day makes. Ultima Thule is finally revealing its secrets to us. And even though it is a pixelated blob still, it's a better pixelated blob than the day before. And in fact, these images that we just got and that we're showing you today have allowed us to resolve something that was really puzzling to the scientists, because we knew that we were pretty certain that it was elongated, highly elongated, and it must be spinning. And in that kind of a situation, you'd expect to see brightness variations. Here's an elongated object, this pin. And as you imagine the camera looking at this pin, when it in this dimension, in this direction, you see a lot of area, and you flip it like this, and you see hardly anything. We expected to see these brightness variations of Ultima Thule over time, and we weren't seeing that. Well, that's because the pole is almost pointing towards the spacecraft. Like this, it's almost like a propeller blade that's running around, and that explains everything, basically. There's no change in the brightness because we're always seeing the same side. But there's definitely, brightness, there definitely is a highly elongated shape. So, and we're now working on the, exactly how fast it's spinning. And if you look at this little, once again, we got these pixelated blobs, and the science team is making as much as squeezing as much as we possibly can out of images like this. But even from these images, you can see these are taken about an hour apart. Let me just show you an artist, representation of what's going on here. You see in one orientation, this first one to the far left, and then about 1 hour later, you see it's moved. The whole thing is rotated in our field of view, and then another, hour and a half later, you see it moving again, and that's how we tell what the rotation rate is. But the data are still not quite good enough to be able to tell the difference between a 15-hour period and a 30-hour period, or, as Alan said also, we're not positive that, in fact, the two things are actually stuck together like this, two lobes. But we're going to, this will all be revealed either tomorrow or the next day. It's just going to be dramatically different. It'll be a completely, Ultima Thule will be turned into a real world after, you see the images tomorrow. And then I think that was my last slide, yes.
Okay, so we will open it up for questions. We'll start with the media here in the crowd. So if you have a question, raise your hand and we'll get you a microphone. And when you get the microphone, please say who you are before your question.
Oh, hi, Marcia Dunn, AP. Bowling pin or peanut, sort of looks like a peanut to me. That must be a huge surprise, because the two orbiting smaller pieces, or a dual thing like this, just wasn't really on your #1 list, was it? Just how surprised are you to see something like this?
Well, we had an event in the summer of 2017 in which we painted out the silhouette of Ultima as it crossed in front of a star that we were able to observe from Argentina. And that gave us a pretty solid indication that the shape was elongated and probably something like bilobate, very much like this. Al, you want to add anything?
Yeah, I'd like to add one thing, and I think that's Marcia. In fact, most of the small bodies in the solar system are highly elongated. And so we were expecting that, because they just don't have enough mass to force themselves into an almost perfect sphere, they kind of come together from the material from which the solar system formed into these clumpy things. And that's what you saw, for example, in the case of comet Churyumov-Gerasimenko, the target of the Rosetta mission. It was a bilobate object, and that's common among the cometary nuclei and among the asteroids. So, in fact, we were expecting to have something that's along these lines.
Okay, next question.
Thank you. Tarek Malik with Space.com. And I think for Alan and Alice, this isn't your first rodeo with a flyby, but it seems like it was definitely a different experience. And I'm wondering, kind of as you were waiting for that downlink, what was that mood in the team? Was it a similar feeling? Was it completely different? I know it was kind of pins and needles here in this audience. Thanks.
Yeah, why don't you go first?
Yeah. It was a little bit different. And part of it had to do with the timing of it. If you remember at Pluto, we had the flyby actually occurred in the morning about 7 a.m. And then we had contact with the spacecraft in the evening about 9. And so we pretty much spent the whole day here. And so this one, we celebrated at night, a little after midnight. And then we went home and then came back early in the morning. And it was this feeling like, gosh, we already celebrated, but we really haven't gotten that signal back from the spacecraft. So, it's a little bit different feeling. I think I was probably a little bit more nervous this time. But again, we did it again, so it's fantastic.
Well, I had a different view of this than Alice. I was extremely confident in the spacecraft and our team. And I had just a normal morning coming into work and wasn't worried about it. I got a nice night's sleep. But I will say that the New Horizons team makes it look easy. It's not easy. All these projects in spaceflight require enormous attention to detail and really smart and dedicated people. And this project's no exception. This team spent 3.5 years working its tail off to really make sure that this would go by the book. And from everything we can tell, they scored a 100 on the test. It really, really worked out.
Okay, next question.
Hi, folks. Congratulations. Matt Kaplan from the Planetary Society, Planetary Radio. How long before the very highest resolution images and the color images might start to appear?
Well, the color images will start to come down this week. They'll be low resolution, so what we'll actually do is we'll take the somewhat higher resolution panchromatic or black and white images, and we'll drape the color over it to give you our best impression of what Ultima looks like at high resolution, but in color. And then over time, we'll get better and better resolution in both the color and the panchromatic. The very highest resolution panchromatic images won't come down until about February.
Okay, next question.
Thanks. Chris Lintop from BBC Sky at Night. I know a huge amount of work goes from getting the raw data from the spacecraft to even the few pixels that we saw just now. Hal, could you talk us through what happened overnight? I know people were working hard to make that image, and people were beaming yesterday morning when they thought they had it. Can you tell us a bit more about that process?
Sure. So last night, an hour before the closest approach, the spacecraft was incredibly busy. We squeeze every single observation we can into that time period, taking the highest resolution images, but instead of sending those data back to the Earth at that time, we want to have the spacecraft pointed at the target and optimizing the scientific return, and including these highest resolution images. It'll hopefully be successful, the ones that where we, at the time of closest approach, required perfect pointing almost, and we think, based on everything we've seen so far, that that was achieved. So as Alan said, the highest resolution images probably won't come down until about February, but tomorrow and the next day, Ultima Thule is going to be a completely different world compared to what we're seeing now. And we'll finally start to see lots of detail on the surface, and all of those data were taken, just a little bit earlier than those highest resolution images. But, we're really looking forward to that.
Okay, we're still here in the audience, too.
Kelly Beatty from Sky and Telescope for Alice, because I can see you and no one else I can. Is there anything about the positioning of this peanut in your field of view that gives you confidence or concern that the very highest resolution LORRI images will be successful or not?
So from an operations point of view, we did everything that we were asked to do by the navigation team, and we believe that it is going to be centered. That's really a science kind of question as to how much we're going to get and what the expectation is.
Yeah, Kelly, let me set your expectations on this. This was really a stretch goal for the spacecraft. If this is the target, as we were screaming by at 32,000 miles an hour, we took a series of images along the pathway of the air ellipse, but the spacecraft only had time to capture one row, and so unless the frames were perfectly centered on the target, we will have missed part or potentially all of it. And because it is a stretch goal, we wanted to try it, and we hope that it worked out, and we're going to find out somewhat later. But the images that will start to come down this week will already reveal the basic geology and structure of Ultima for us, and we're going to start writing our first scientific paper next week.
Okay, another question.
Hi, Lisa Grossman from Science News. So the whole idea of visiting this object was to study something really primitive and old. Does knowing the rough shape, this bowling pin shape, tell you anything about the conditions in the Kuiper Belt or the protoplanetary disk?
Yeah, it certainly does. As we were talking about earlier, how these objects come together, how they're built up, either from the growing material, clumps of material that come together versus being collisional fragments, for example. We hope to be able to tell from looking at these details on the images. But in addition, just the number of features on the surface, the number of craters. This thing has been sitting out at a large distance from the sun for 4.6 billion years. And it could be, the surface could have been pummeled by meteorite-like material over the age of the solar system and producing craters or not. If this object, for some reason, had been, there's a process that causes the surface to change over time, it would wipe out these craters, for example, if they were there. But anyway, these are the kinds of things that will tell us about what was going on in the early solar system.
Okay, we can stay here in the audience too, so we'll run in the microphone.
Hi, Christian Reddy from Launchpad Astronomy. I'd like to ask the team, how might you be able to assess Ultima's mass via either its rotation or any potential satellites or other techniques?
Well, the easiest way to get Ultima's mass will be if it has satellites and we can actually determine their orbits. And from that, we can use Kepler's laws to directly determine the mass. But if it doesn't have satellites, we really don't have a direct way of being able to do that. We We do expect to be able to determine its shape entirely and at pretty good accuracy, so we'll get its volume, but we won't be able to determine its mass unless it has a satellite, because we flew by at a distance that its gravity just didn't bend the spacecraft trajectory enough to be detectable, even with these exquisite tracking techniques that NASA has.
Hi, Corey Powell with Discover Magazine. I'm curious, what's the timescale for some of the specific science goals for getting those data, especially for getting the ultraviolet spectrometer data that'll start to tell you about composition, and when you'll know whether or not the radar experiment was a success or not? What's the timescale for finding these things?
Well, this mission's always been about delayed gratification. It took us 12 years to sell it, it took us 5 years to build it, and it took us 9 years just to get to the first target. So, Corey, you're going to have to wait just a little bit. We're going to be getting great data this week, but then next week, the spacecraft is in solar conjunction, which means that we can't communicate to download more data because of radio interference from the solar corona. But then following that, in the middle of January, we'll pick up the data transmit again, and we've made a very detailed plan over the next 3 months of the first data sets that we want to get to the ground, in what order we want to send them to the ground. And we're starting with our highest priority objectives of mapping the surface, looking for satellites and rings, and mapping the surface composition. And when I say mapping the surface, we do this half a dozen different ways. We map it with the panchromatic LORRI camera, we map it with the Ralph color camera, we map it from different angles to get stereo, and then we map surface composition in addition. And some of all of those data sets will start to come to the ground after we get back in business in mid-January and across the next couple of months. Bonus objectives like the radar experiment that you spoke about is going to come much later, because that's really very far down the list, and we take this very seriously, this business of spaceflight. Even though the spacecraft has performed perfectly now for almost 13 years since it was launched, there's always the chance that something could go amiss. So we want to start with the highest priority objectives and then move to the second highest priority objectives and only pick up the bonus objectives at the end. So, Corey, you're going to have some of that delayed gratification love that our team has.
Stephen Young with Astronomy Now magazine for Alan. Could you perhaps give us an idea of what the science team's going to be doing over the next few days? Obviously, the first data will be coming down tonight. And how long will the team stay together here? Will you break while the spacecraft is in solar conjunction and then reconvene?
Yep. And Hal may want to add some to this. Science team will be in place for the rest of this week, working very long days as we did yesterday. In fact, I have meetings on my calendar with science team until 10 o'clock tonight, East Coast time, and then we'll be back at it again first thing tomorrow, and then again each day this week through Friday night. Then we'll take a break with that solar conjunction, and we come back together as a science team on the 15th to start working on the data again.
Yeah, we actually have a formal science team meeting, as Alan said, starting on the 15th, and after everybody has regrouped and been at their home institutions looking at the data, we'll come back and trade stories about what we found. Everybody's going to be looking intensively. January is going to be an extremely intensive month.
Yeah. I think we can do a couple more questions here.
Hi, Ken Kramer from Space Up Close, Northeast Astronomy Forum. One of the things that I think you mentioned, it could be 2 objects instead of 1. So if it is, what does that tell you, and how common would objects like this be so close together? And if it is, then can you figure out the mass, and what impact will that have on the image smearing? Thanks.
Well, I'll start, and I'm sure Hal has things he wants to add, but let me start by saying my bet would be that it's probably a single object. It's bilobate. And if I'm wrong, I'll tell you tomorrow. If it's 2 separate objects, this would be an unprecedented situation in terms of how close they're orbiting to one another. And it will be spectacular to see. And I'd love to see it, but I think the higher probability is that it's a single body. As to the interpretation, let's figure out which branch we're on. You only have to wait until literally tomorrow, and then we'll work on the interpretation. Hal?
Yeah, I completely agree. My money is on the single body, bilobate, because that's pretty common among the small bodies of the solar system.
Okay. Okay, any closing thoughts before we break, team?
Alice?
It just keeps getting better and better. I mean, this is the science team is.
Yeah, I think what is striking home with me is that we can build a spacecraft on Earth and we send it out billions of miles away from Earth, and it sends us back all this wonderful data that we get to look at and learn more about our world, our solar system. And long after that power is so much less that we can't turn around and communicate to Earth, that will keep going on. And that's a bit of all of us on that spacecraft that will just continue after we're long gone here on Earth.
Chris?
Yeah, I just wanted to say it's an amazing thing when a nation pulls together to collect the funds to do this challenging accomplishment, and then the team pulls together, sleepless nights, double-checking calculations. We have two teams from the East Coast and the West Coast, everybody working together, and I'm just thankful to be a part of it. And I'm thankful that we can share all this with all of you as well.
And I just want to close, I'm going to echo a little bit of what Chris said. I want to say thank you. Thank you to the entire New Horizons team. Thank you to APL and SWIRI and all of our other partners. Thank you to NASA for selecting our team to go and do this mission to the farthest reaches of the solar system. And frankly, thank you to the United States for being the kind of country that it is that makes history this way in front of the whole world. Thank you.
All right. Well, panelists, I'll thank you for joining us today and for all the information and the stories you've been able to share with us today. So I will remind our audience that you please continue to follow New Horizons online. We're on nasa.gov. We are on pluto.jhuapl.edu. We are on NASA and APL social media channels, and we're on NASA TV. So join us again tomorrow. Expect to be about 2 p.m. where we will see an even closer look at Ultima Thule and begin to reveal the mysteries of this distant world. Thanks again for joining us, and keep on exploring with New Horizons.
So sorry, everyone. I like to be muted. Um, so that concludes our coverage of the New Horizons flyby of Ultimate Thule, coming to us from Johns Hopkins University's Advanced Physics Laboratory. While this concludes things for today, the story is not over. Tomorrow we will be getting back, hopefully new and better images of this small object or objects that we still don't understand. We do have some new information on the system. One of the great mysteries that we've been dealing with is, why does the thing have a constant light curve? Why does its brightness not appear to vary? Well, what we're learning is, instead of rotating like this, which was kind of expected, where the surface area that is facing towards us is constantly changing, it is instead rotating, we think, in the plane of the sky, meaning that the area that we see doesn't change, so the brightness doesn't change. Whether it's a 15-hour or 30-hour rotation, we don't know yet, but hopefully tomorrow we'll find out. And we also don't know if it's a single object or two objects very close together on the sky. The great debate of Twitter is, does this look like a peanut, a bowling ball pin, or, if you're me, one of those clown punching bags from Bugs Bunny that always stands up and somehow hits Bugs in the face? So that concludes all we know for now. We will be back in 1 hour's time for the Daily Space. Until then, go out, get more coffee or something perhaps a little bit more advanced, all depending on time zone and inclination. I, for one, am going to stick to the coffee and stick to the science. Thank you so much for joining us. This channel is part of CosmoQuest. We are a program dedicated to putting science in your heads. Normally, I would say join us over at CosmoQuest.org, where we are working to map out the solar system, but we're in the process of massive software upgrades. So to you, it currently looks like a standby page. To us on the back end, things are exciting and changing, and I hope to be able to bring you all these updates soon. So for now, join us on Discord and keep the conversation going. As I said, we will be back in 1 hour's time for the Daily Space. Bye-bye.